So this particular question, what happens to the vertical geometry when I create a complex alignment? Well, in this case, you may have many pieces to an alignment, or many complex alignments that you need to stitch together. So this is really trying to understand some of the complexity behind the rules for the vertical creation. So let's take a look at this.
Let's take a look first at a simple example of design intent in vertical geometry. What I've got here is I've got some individual pieces of geometry over here, and so you can kind of see as I move around I can select in each of these individual pieces. Now the other thing I've done is I've actually got profiles here for all 5 of these individual pieces. So here you can see this is the existing and proposed profile for this first segment. Here in the middle I've got segment 2 and segment 3, which I only have existing profiles. For segment 4 here, you can actually see I've got an existing and 2 proposed profiles for that. And then for the last segment here, for the remainder of the project, I've got an existing profile and I've actually got a best fit profile. Now another thing to notice about this is you'll notice that this profile for segment 1 is active, and the best fit profile for segment 5 is active. But in segment 4 right here, neither one of these profiles, even though they're both proposed, neither one of them are active. Now, what I'm going to do is we're going to create a complex alignment out of this individual geometry. So the first thing, let's make sure this is set to automatic. And so I'm going to select that first element, and then we're going to accept it, and we're going to complex it. Okay. So now you can see if I go in and pick this up, that I've got the whole thing is highlighted. So what I'm going to do is I'm going to hover over this, and I want to open the profile for the entire complex alignment now. Now, what I want you to see is what it did. What it did is it actually took the individual pieces of the individual profiles and it attempted to create a new complex profile. But notice that because this one was active and this section here was active, it put it in there. And because this best fit here was active, it put it in there. But notice that section section 2 and section 3 had no profile, and this profile here had no active. There's nothing there. Now I can come back to the individual ones here and actually set it active, and you'll notice that it will actually put that profile in there. So I can come back to the other individual, set it active, and it'll actually modify that profile. The interesting thing about this is this. Let's come in here and let's design a profile between these two. So I'm going to do a profile curve between elements. I'm going to identify that with an offset of 0. I'm going to identify that with an offset of 0. And let's just put a 1200 foot vertical curve in there. And let's trim and extend both of those so we can kind of see them. All right. Now notice that if I select that profile, I can actually edit that. It's active and available to edit. So let's say change that to 1000. But you'll notice this one has no element handlers because this profile is actually over here in the individual profile. So it remembers the relationship or the link between the original profile and the new complex, and the same thing here. But I can easily, for example, come over here and change this to a new one, and this will just automatically, this one will automatically update. So it allows, it's just an example of design intent being part of the command, that you can design individual profiles, and then when you complex the alignment, it'll actually maintain that relationship to the individual profiles.
So just sort of summing up what we've seen there, it's not really a simple example, it's quite a complex example, and it deals with reversing of elements, setting active profiles and propagating them forward, but it shows some of the complexity that you can achieve and intelligence that you can achieve. So with a profile, if we have an active profile on an element, when we create a complex, it brings that instance forward and makes it available for us to use, but we do not get the manipulators on it. So you have to navigate down, and that's where Project Explorer assists you in that. You can navigate down and get to the original element and open that up and profile it. Now this really helps us in terms of situations where we're working across reference files, because the reference file will contain the original profile that we may need to go and edit. So be aware of that you may need to go down and navigate through some of these reference files to manage some of those edits. And key thing to remember here with all of your vertical geometry is that for reporting and exporting back to Native Product, it's always a good practice to name the vertical profile, especially with multiple profiles. So name them, understand what these profiles are. So another common question that we get is, as we start to build up this complex geometry and we start to carry the design forward and start applying corridors and super elevation, what actually happens if we need to go back and do the edits? How does that edit get propagated and how do we manage that? So let's just take a look at that.
Dynamic updates are not always desirable. You need ways to control this. This is achieved through the rule engine for the geometry and unlocking referencing rules. This will allow me to make geometric edits, to delete a vertex, and if I want to simplify this geometry and take out the tangency, I can take out the end IP, or the end tangent point I should say, and then the intervening IP, and I've simplified the geometry down. None of the updating has occurred. If I now activate the referencing rules, so now I need to trigger an update, and this is essentially done on the next geometric edit. And now we get the dynamic updating. So in this instance, all of the geometry rules are then followed through, so the super elevation and the corridors all update. This doesn't occur if you're running across reference files in a federated workflow, segregating out super elevation and corridors into separate files.
So a few things to pick up on from a best practice really here. Dealing with complex geometry and editing, it's quite common that you may need to sort of insert and remove curves, and there are commands that will assist you in this. But if you're trying to delete a curve, you can just utilize the microstation delete point. But if you're doing this, you need to consider the direction of the geometry that you're working on. Delete the forward tangent point that occurs after the IP first, and then remove the IP itself. Then you'll get correct updating. If you get the order wrong, just undo it and then reapply. If you're inserting, again, the insert vertex command will work, and then you can insert a horizontal fillet, or you could just use the civil horizontal insert fillet, and it'll actually take through the process of inserting a vertex. You may also want to consider locking the rules to control the updating, but again, if you're working in a federated approach, you have control then, because the federation across reference files occurs when you open the reference file. So you have several methods of actually controlling when some of these updates occur, and with some quite complex edits and manipulation, you don't necessarily want all of those edits to occur at the time that you're making them. You want to daisy them up, so you need to lock the rules to cause that update to occur as a global thing. And that's really the key aspect, is how do you manage that federated approach and deal with the reference file manipulation and control when the update occurs. And that's an advantage to using reference files, because it gives you more control rather than having everything live and updating all the time in the one file. So I keep talking about federated data and working across reference files. So let's take a look at how that updating occurs when we start making changes in a federated example.
For instance, I'm going to switch just into the geometry. So we'll make a few changes now that are going to cause an update. So let's pull this base geometry around, change the radius, make a fairly significant change there, just check that it's not updated. And the other one that I'm going to change here is perhaps this end piece of geometry. Make a modification to the entry bearing on that radius, on the roundabout that's being put in there. So that will cause a ripple effect into the civil cell as well. So there we have some fairly significant changes just occurring in the side road for this main alignment on the side road. Obviously the corridors may be in a separate file, so may need updating. There's interaction between the various files. So if we save and then switch back to the previous file, what we will see occurring is a series of updates. So the side road corridor that's been affected will be updated because it's classified as being dirty and needs updating. The civil cell will update, reflecting the changes to that base geometry. The corridors have updated.